Welcome back. So let's figure out what the hypotheses are in these examples. Researcher wants to know if the percent, that's the same as a proportion, really is greater than 2%. So the statement that the researcher, or whatever it is and the problem is wants to investigate is always your alternate hypothesis. So this is that proportion is greater than 2%. Of course, we put our percents in decimal form. The alternate hypothesis is always going to have an equals in it, and it's always a statement that, so let me say the sort of nuts and bolts practical here. The null hypothesis is always going to be the same as your alternate hypothesis, but with an equals in there. Okay, so and then what I would, let me go back to what I was going to originally say, which is a little more theoretical. The null hypothesis is a statement that there's no difference. In other words, that the 2% from the competing antibiotic still holds, that proportion is going to hold here. There's no difference between our new antibiotic and the competing one. Okay, but again, you can construct your null hypothesis by just taking your alternate hypothesis and sticking an equals in there instead of the inequality. Okay, type of test, since this is a greater than, it's going to be a right-tailed test. Next, car buyer wonders if the mean price, so that's a statement about an average, a mean, wonders if the mean price of cars in his city is different than, so not equal to 86,012. The alternate hypothesis, you're going to take exactly for the null hypothesis, you're going to take exactly your alternate hypothesis and just change to an equals. Change it to an equation. Okay, so that's your null hypothesis. And type of test, with a not equals, that's when you have a two-tailed test. Okay, and last, detergent manufacturer wants to know if a new machine has less variability. So the hypothesis to be investigated is standard deviation being less than 0.23. The null hypothesis then would be standard deviation is still equal to 0.23, so no difference. And with the alternate hypothesis being a less than, that's a left-tailed test. Okay, hope that went okay. So we'll go on now and talk about, so by the way, we're not even going to get in this section to how do you test a hypothesis. All we're talking about in this section is what's a hypothesis, how do we talk about hypothesis testing, and now what we're going to talk about is say you've done your hypothesis test and you're drawing a conclusion about the claim, what are the possible outcomes? Okay, so we still don't know how to actually test a hypothesis. We're just talking about how do you think about it, and in the rest of this chapter we'll talk about how do you test them. So you've got some hypothesis, you've got your null and your alternate, and after testing them, you could decide to reject the null hypothesis because evidence supports that the alternative hypothesis is true. Now, if you reject the null hypothesis when the alternative hypothesis is actually true, in other words, the evidence suggested that the alternative hypothesis was true, and in fact it is true, and fortunately your evidence suggested that what is in actuality true, so you reject the null hypothesis. In other words, you then are making a correct decision or correct conclusion. Similarly, if you don't reject the null hypothesis when the null hypothesis is true, you're also making a correct decision. Okay, so here, remember, either H0 or H1 will be true. Okay, they can't both be true, right? The H0 will always be an equals, and the H1 will always have something else other than equals, either greater than, less than, or not equals. So in possibility 1 here, we're rejecting the null hypothesis when this one is true, and that's good. So if you reject the null hypothesis, you're going to say that there's evidence to support H1, and that's good because H1 is true. Other possibility, so the next possibility here, is that we're not going to reject the null hypothesis. So we do some testing that leads us to not reject the null hypothesis. In other words, we're going to say that there's not enough evidence to support H1. So we're not going to reject this one, we're going to reject that one. If the null hypothesis is true, then that's good. We've rejected the one that's not true. But that isn't that nice correct outcome or conclusion. Those aren't the only possibilities of what could happen here. So it's possible that we might reject the null hypothesis when the null hypothesis is true. Now, why would we do that? Well, it would be because, so let's see, this is the true one, and yet we reject it. Well, why would we do that? Well, it would be because the evidence from our sample seems to suggest that, seems to support the alternate hypothesis, H1, not H naught. And that can happen, right? Because we're drawing these conclusions based on samples, not based on the whole population. So if you're unlucky in how you draw your sample, you can draw the wrong conclusion. Okay, so this clearly is an error, and it's called a type 1 error. And then the other possible error that can happen, so here's your hypotheses. If we do not reject the null hypothesis, in other words, we reject that one, and yet in reality that one is true, then we've made an error, and that happens to be called a type 2 error. And again, the reason we would reject the true one is just that our evidence doesn't lead us to think that this one's true. It's not that we're willfully rejecting the true statement. It's just sometimes your evidence is misleading. So let's see. So next we'll go on, and I've got a chart for you to help maybe sort of organize and give you another way of thinking about these errors. This video has gone on long enough, so we'll come back and do that in the next video.